All right, guys, welcome to the next part where I'll show you writing the infrastructure code for this, right? Again, this is not a beginner level video. Again, this is not a beginner level video. We are designing an entire pipeline. Again, if you are a beginner, I'm sorry, this is for advanced level only. So the first part, again, just reviewing your memory in the first part, again, I have listed all the links. We did a basic data modeling, right? And then in the second part, we essentially wrote our infrastructure code. We populated our DynamoDB table with fake user. User can have several posts. Posts will have likes, share, comments, stuff like that, right? Now, I'll show you the entire infrastructure code that I have written. So again, we are developing an aggregate pipeline, which means anytime a user like comment stuff, it'll be streamed to Amazon Kinesis. Kinesis will fire up a Lambda. Lambda will put to SQS. SQS will do a long polling, will batch the data for the Lambda, and this Lambda will insert into dev.linkedin aggregate, which will essentially give us stats about every single post, like, interaction, every stuff, right? So we are building this entire stack, okay? So yeah. So hopefully this made sense in the last video. Post will have several likes, right? Post will have several comments, and now we want to build an aggregate pipeline. So this is exactly what we are building. Anytime a user likes, comments, we want to do that, right? Again, if you observe the way I have structured the project, so come here, it's a project file. Where you go? Yeah, project, then you have data modeling exercise. That is where we did the data modeling. This is the Python file to populate the DynamoDB data with fake data, right? And now let's see the infrastructure code. Please don't get overwhelmed. There's a lot here, so do not get overwhelmed. Okay, so here I'm defining my service as DynamoDB aggregate pipeline. Here I'm defining my stacks and I'm defining my tags, right? So if you observe my architecture, the first piece is the DynamoDB table, right? So over here in the resource section, not this one, here, I'm creating my DynamoDB table. If you observe, this is the table name, and I'll show you the env as well. So here, so this is where the dev.linkedin, it's gonna make a table. And here, I'll try to go slow here. We are defining all the attributes, right? PK, SK, all my global secondary index. This is coming from part 1. So you should be familiar with these, okay? Here I'm saying that I'm gonna have a Kinesis stream enabled, right? I'm defining my key schema. Billing mode is on demand. Table class is standard. I have 3 global secondary index. This is my index 1, which will give me all the interaction by a user. This is my second global secondary index, which will basically, for a given post ID, it will show me all the user who commented on the post. This is my third global secondary index, which will show me wait, did I? No, this is right. Yeah, this is the global secondary index for a given post. It will give me all the comments by a particular user. Then my third global secondary index is for likes. For a given post, show me all the user who liked on that. So these are all my global secondary index. I'm projecting all the keys here, and hopefully this made sense. PITR, I can enable it, but for the part I don't want to do it. It's essentially for point-in-time recovery backup. Now, if you observe, the first block was the DynamoDB, which we made. Now, let me show you the Kinesis part. This is where I'm creating a Kinesis data stream. If you observe here is my Kinesis stream name, which will come from here, LinkedIn stats. That's my Kinesis data stream. Here I'm defining my retention period and I'm defining on demand. For everything I'm defining on demand, because when it's a new project, you don't know the workload. It's usually good to go on an on demand mode, okay? So if you observe now, this is the second part. Again, I'll move my pointer, so if hopefully this made sense. So we went over this architecture. Now we went over this particular block that is here, right? Now let's go over to this Lambda. So lambda here, function. So this is my Lambda function. As you can see, Lambda function dot Lambda handler. Here is all the environment variable, and then here is the event. This Lambda will be fired through a Kinesis data stream. Here I'm giving the Kinesis data stream on. So basically when the data comes, when the data comes in here, it goes to the stream, it goes to the Lambda. Lambda will convert the data from Dynamo JSON to our standard JSON, and it will pass it on the SQS, okay? So now let's see the code for that. So if you observe carefully, I'll go to the Lambda function, and here is all my code that I wrote, okay? Again, pretty easy and standard. Here I'm defining all my class, all my imports here, and I have 2 methods, Marshal and unmarshal, which will convert the data into Dynamo records. Now, when the data comes from Dynamo, it's either insert, modify, or remove, because it's a stream, right? Based on that, I'll grab the copy of the data, and then here I have to write the code for publishing the data to the SQS. So hopefully this is my template, which will take the code. Again, this will take the data from stream and it will pass it. It will convert the Dynamo JSON to a regular JSON and pass it on the SQS. So now let's move over to the SQS block, right? So I'll collapse this one. Here is where I'm defining my queue. Here, if you observe, here is the queue name. I'll be giving, hopefully you can see, LinkedIn stats queue. I'll also have a dead letter queue. So if anything fails, it will go to the dead letter, right? So coming back to the YML, visibility timeout is always twice of that of Lambda. So this is my visibility timeout. Message retention is for 14 days. Maximum size is 256 kilobytes. Was it 256 kilobytes, yeah. And then I have a DLQ read-write policy, and here I'm creating my dead letter queue. So anytime a Lambda fails, it will try for 3 times, and after the third failed attempt, it's gonna go to the dead letter queue, which is LinkedIn stats dead letter queue. So this is my entire infrastructure code, 147 lines, I believe. Yeah, 147 lines. We created all the resources, and at the last is, so I showed you the SQS and the dead letter, right? Now I'll show you this Lambda. Again, I have to write the code. So this Lambda will get the batch of data, right? So this is gonna be over here, Dynamo stats. So here, this Lambda will be using PynamoDB library and will essentially generate the stats, which we discussed in the first part, okay? So that's this Lambda over here, which is basically triggered by an SQS. Here is the ARN, right, of the SQS, and we are generating the SQS queue over here. Hopefully that made sense. And that's why I said it's not a beginner video. So if you know what I'm talking, it will make sense. Now this part is done. Now this is the stats table. So anytime people like, comment, share, view, all that interactions flows through Kinesis, will flow through Kinesis Stream, Lambda, SQS Lambda, and Dynamo. So this table right here, we are defining the table on the bottom section. That is here. My stats Dynamo. Here I said type as DynamoDB table. Here, if you observe my naming convention, it's pretty generic, PKSK, right? So this will hold my stats, right? Again, key schemas, right? Standard paper request, which is an on-demand mode, and PITR is false. So this is the entire architecture. We talked about this, right? So anytime, again, we went through the modeling exercise. You have been through me. You have been with me on these, right? Hopefully. So whenever a person like, comments, does any interaction, right, we will flow these events in real time to the stream to Lambda. Lambda will do some pre-processing, and then it will dump into an SQS. And from this Lambda will take the messages from the SQS, will do batching, and it will update our stats table. Makes sense, right? Again, I'll leave the entire code for the project in the description, so do check that out. Quickly, I'm gonna share my screen. Hopefully it takes a while to load my camera here. So I wasn't just saying, when I say I'll make it, I'll make it. And it was very easy to build this, right? I was able to do all this in a matter of like 20-30 minutes, of course, because I have worked a lot on AWS. I have been working on cloud every single day. So for me, it's a piece of cake now. So entire infrastructure is ready. Now all I gotta do is add the business logic for the stats, and then I'll show you the actual demo end to end. We'll run the script. Fake users are coming in, they're commenting, they're liking, they're doing all this interaction. They are being captured on Kinesis, and I'll show you the stats. So that's the next video where I'll just complete and show you the demo. Hopefully this made sense. And the infrastructure code is in the description, so check that out if you have any more questions. With that being said, thank you so much for watching. I'll see you in the next video, which is the final part where I'll be showing you a demo end to end. Thank you so much.